Hello, everyone. This is Rona Palmer from eMaint Enterprises, and I'd like to thank you for joining us for this month's Best Practices webinar. And I'd like to start by clarifying the purpose of the Best Practices webinars, because as you know, eMaint is a software provider of CMMS software, and as such, we do offer quite a variety of educational offerings and different webinars and educational programs, including product demonstrations. But our best practices webinars are a little bit different. And Alex, if you can advance the slide, our best practices webinars are focused not really on software per se, but on maintenance strategies. And toward that end, we bring in speakers from a variety of different industries and backgrounds to share their knowledge. And as many of you are probably already aware, eMaint became part of the Fluke family last fall. And that was really an exciting event for us because, well, for many reasons, but it did open us up in this webinar series to a host of guest speakers and subject matter experts from Fluke Corporation. And one of them is with me today, and I'm really pleased to introduce Alex Desselle, who's a product application specialist with Fluke. And he's going to be presenting today's topic, which is focused on baselining and trending asset data for predictive maintenance. And a little background on Alex, for those of you that don't know him. He's had over 30 years experience in field engineering and project management in oil and gas, chemical processing, and has had roles in manufacturing ops and as well as quality control. And Alex, thanks for joining us today and for putting this together. And I do know how busy your schedule is, so we really appreciate it. And maybe while we're giving listeners a few minutes to log in, can you just tell us, Alex, you're out on customer sites a lot, and what is it that inspired you to choose this topic, and why is baselining and trending something you wanted to share?
Good morning, Rona. Thank you very much. Alex Desselle here. Yes, it's a good question. I do get out in the field quite often, and I've really spent most of my life out in the field working with customers at different locations and also attending trade shows and different events. And one of the most common questions that comes up, or what I see challenging for the customer, is understanding, how to actually baseline an asset and knowing when to react, when that asset is starting to show signs of problems. And what's the criteria for the reaction? What's the criteria for setting a baseline? Many times the baseline itself is not really, all the variables are not really considered all the time. And so it's just I really like this topic because it comes up all the time. And yeah.
Excellent. Well, I know that, that's something we hear as well in service and support is like, I have all this data, what do I do with it? So we appreciate it. So before I turn things over to Alex to do his presentation, a couple of quick items. I want to let you know that we're recording today's session, and we'll be sharing a link to the recording with all of our listeners. Alex has agreed to stay through the hour and answer any questions that you might have. But please feel free to type your questions into the questions box and go to webinar at any time, and I'll read them to Alex at the conclusion of his presentation. He also agreed to share a PDF. So we'll share that, a PDF of the slide deck. We'll share that as well at the conclusion of the presentation. So with that, I'll turn things over to Alex to get started.
Will do. Let's start with a poll question.
Okay, let me go ahead and launch this poll, all right? And maybe you can start by telling us what really applies to your organization. Where are you in this continuum? And let me start by saying Alex included a few polls. The answers are only in aggregate. There's no wrong answers. And it's really to make this interactive get a feel for who's on the line today and to allow you to each benchmark where you are relative to the rest of our listeners. All right, so just go ahead and type, where is it you are today? Are you more reactive? Are you more planned? Or are you more in the predictive category? All right, looks like reactive, planned, predictive. No assets fall under predictive, I see. So tell us if A, B, or C characterizes what's closest to you. All right, looks like we've got, Alex, the votes in, so let me go ahead and share the results. So it's an interesting split. 48%, almost half, said asset maintenance is more reactive, a little typo there, rather than predictive. 44% said it's more planned than predictive, and only 8% says no actives fall in the predictive maintenance category. All right, back to you, Alex.
Thank you. Okay, that first poll leads into this next slide here, and it's interesting the answers that we received on this. Many times I hear the reactive story, traveling around. A lot of times it's because of bandwidth. With the maintenance department, usually people are spread thin, and it seems to be the trend as we go. But I think we all would agree, we're trying to get to a predictive type of maintenance situation where we have early detection, which is to prevent, prevention of the problem before, or detection of the problem before it occurs. And this is the whole reason for the presentation that I'm giving today is, how can we get to that point? Obviously, this takes, and we're going to find out, this takes more than just software or one tool to get us there. It's really a behavior, as part of that journey. But yeah, it's everywhere I go. It's really a similar split, but I think things are trending in that direction, be more predictive. Okay, so as you can see, we got the gears all turning together, and hopefully all mesh together. There's a few steps to get to the predictive maintenance type of asset management. And the first step, as you can see, is the establishing the baseline, and then from there, we can trend that data, and from that point on, we can go to the predictive maintenance. We can say we're there, which is the biggest wheel we see right there. Now, talking about baseline data, what is baseline data? And many times, I think most people have a good understanding of what baseline is, and it's really just it's a comparison against a standard or control sample, a situation that we can call sometimes known as normal operating conditions. But the key is to understand all the variables that go into the output of that particular asset. I remember early on in my career, I started out working in the rubber chemical industry, and I worked at some rubber chemical plants in the Louisiana, Texas area, and some major producers of rubber that would, the raw polymers that would supply the tire manufacturers in different places where they process rubber and plastics. And my role at the time was actually supporting laboratory information management systems, and I worked in quality control laboratories. And many times the test instruments that they were running the data on for process control, quality control, were they're wondering if they're in calibration or not. So they would get a reading, at every half hour. For instance, at this one site, they would send a sample in of the raw polymer, and they would take several different readings. And sometimes if the reading did not fall within the criteria, the question is there something wrong with my output of my instrument that's measuring it, or is it something wrong with the process? I usually felt like sometimes I was under a lot of pressure because they were the instruments I was supporting, they were really could change the way they would, actually produce the product. So I was very, very careful, and I would take standards with me, had NIST traceable calibration standards. That could be a dead weight. In some cases, it might be a control sample. But the idea is that how do you check it? How do you know for sure that you actually have that the output's reading right? So if you have a way to introduce a calibration or to verify the calibration, that's the easiest way to do that. But the key is on the baseline is understanding all the variables that go into having a true control sample and a true comparison. Because everyone knows, and I've heard this before, we'll call it baseline data integrity, but garbage in is garbage out. Is the asset that the data coming from the asset that you're monitoring, is this data, good data? That's the first question that should be considered. The quality of the data coming out of that asset. And there's a lot of things that, if it's a temperature transmitter, it's one thing, right? But in some other cases, some other types of assets are more complex, and there's a lot of other variables that can go into that. So we'll discuss a few of those this morning. The first one is that particular asset, maybe it's a pump, is it actually specified properly for the application? There's been a few cases I've run into out there where they improperly spec'd a pump, was supposed to pump so many gallons per minute, but it was actually not the right equipment for that particular, or right asset for that particular application. So it's worth verifying that. The next one is it installed and commissioned properly? Is there any sort of records on the installation and commissioning of that particular asset? Sometimes if it's a temperature or pressure transmitter, it seems pretty straightforward, but even then, the 4 to 20 signal needs trimming. There's a calibration associated with that. And it's important just to consider, is it installed and commissioned properly? Another one would be what I call upstream and downstream effects. It's good to have an understanding of what other assets or what other devices can affect the output. And so now we're starting to get more than just thinking about more than just the output of that asset. It's not so straightforward. Maybe it is in some cases, some assets could be affected by other assets. A good example might be like an output from a flow meter, where upstream of that, there may be, you're on a header, but there may be some other pipes coming into that header, and some other flows to consider. At some point they all have to balance out. The other another variable to consider is the operation of that asset. Is this an asset that's continually, is it being controlled by a programmable logic controller, or is an operator actually running it? I used to like visiting the tire manufacturers and watching the operators introduce rubber into a calendar. This is something where there's an HMI and the operator's actually controlling, the amount of rubber of this process themselves, the actual asset. They're like driving it, if you want to put it that way. Another case would be like a corrugated box manufacturer, where they're using a laminating machine. And this is a complex type of asset because there's many components of that asset, and it's all driven by one particular operator. And so sometimes these things can be not operated properly, and so it's good to understand that, or to check that off the list. The next variable to consider, the data coming out that you're trying to baseline, is it normal operating conditions? This is probably one of the most common errors that I run across and see many times, is that the new assets installed at a particular location, and the customer wants to start baselining that particular asset, and they choose a period of time to look at the data coming from that asset, but not considering what the operating conditions were at the time. maybe it's a startup condition, maybe it's an upset condition. It could even be shut down and data coming out. It's just important to identify what we're going to call normal operating conditions, because ultimately we want to get an alarm or work order generated when this particular asset exceeds a particular user-defined threshold. So as I mentioned earlier, startup and shutdowns are variable. I think it's good to, if you have the opportunity to actually witness or be part of the startup and shutdown, or just monitor what the asset does during those times. Sometimes right after startup, it could take a few times for an asset to stabilize. If it's like on a temperature control circuit or flow control circuit, maybe they have a proportional band type controller, the overshoot, undershoot, those type of situations. Those are things to consider. Is it right after startup? The same thing applies on a shutdown. Now, it's not so much important on the shutdown, it's understanding what happens after a shutdown. There's been many times when I've been called out to troubleshoot problems, and I start doing the investigation, and I find out that, what changed? It's the first question I ask myself and the customer, and say, what changed in this situation? And something, oh yeah, well, they're just talking to events, and we had a shutdown. And then ever since it started back up, you can see a shift in the trend right there. And so the first thing is like, okay, well, what happened after the startup? After the shutdown, what caused it? And many times there's, I can't tell you how many times I've seen issues where after a shutdown and they start up again, the asset performance has shifted for some reason or another. Okay. Another good one to consider is decision time period for examining the data. What I mean by that is, how much data should we look at to establish the baseline? Well, the answer to that is that if under normal operating conditions, if you know that it's been operating, the more data the better is really the bottom line right there for normal operating conditions. One of the mistakes or pitfalls that people can fall into is, starting to try to establish limits too soon, right after startup, or just maybe after the first day or something like that, or after a couple hours. It might be feasible, in some cases. Keep in mind some assets aren't as complex as others. They come in many different varieties and forms. I like to say, is this part of a system, or is this more or less an autonomous type of an asset? Again, temperature and pressure transmitters and some devices are pretty straightforward, and you could set limits. And another common way is but for more complex assets, there needs to be enough data to be confident that, yeah, I'm truly, at a baseline condition here. All right, another one that I find interesting, I run into many times, is I'm calling it data acquisition, but it's really the output of the asset and what's being captured from that asset. And so this all has to do with sample rate being sent to, if you're sending this data, whether it's to the cloud, a DCS system, distributed control system, a SCADA system, sometimes the outputs of these devices can vary. And what I mean by that is, depending on the type of asset, they can have a type of an output that's pretty noisy, and it doesn't look pretty on the trend. So there's smoothing features on that in the programming of that output. Sometimes they may want to average up to 30 readings. And what I'm talking about is like a boxcar type of averaging, first in, first out. If you have like 30 values of 5, and the next value that comes in is a 6, and then you got another value of 6 coming out, you're throwing out the 5s, your average is starting to change, and you can start seeing your trend change. But really, does the user know on the side that they're looking at that's a smooth output or averaged output? These are things to definitely need to understand about your asset. the sample rate. Is this data coming in every minute, or is it coming in, you know, every second? And if it's coming in every minute, you know, am I missing things I should be seeing in my process? So this is really an important point right here, is understand the sample rate and how often it's being refreshed. And that kind of leads into the granularity of the data. You know, again, you know, how granular is my data? You know, am I looking at the average output, or am I looking at something that's just being reported every so often? Many times, I've seen at a lot of large in oil and gas applications, especially, you know, in a control room, the operator can pull up an asset on their HMI, and they're looking at data. And if you talk to the programmers, you know, they only have so much room that they can get. You know, it may be a Modbus type or 4 to 20 type signal, but they can only handle so much data, and there's only so much room on these servers. So it's not uncommon to have non-granular data coming in some cases. And another thing to consider is that, okay, so far I've really been talking about you know, automatic or just data acquisition streaming from the asset. But there's other types of data too that can be considered into baselining assets. What about the case where what I'm calling route-based data, where maybe an operator or a maintenance tech goes out and takes a vibration reading, you know, with a vibration analyzer, and has to input this reading into a CMMS system? Those are things to consider. You know, what do you think about that? Is the operator actually going out there with a pen and paper, writing this value down, or is it being captured in some digital fashion that can be transferred into CMMS system? Obviously, you know, there's always the human error aspect of things, and there's things to consider about the actual training of the operator themselves. Are they touching the same point? If they're doing a vibration reading on a motor, for instance, checking the bearing, are they, you know, checking the same spot every time? You know, it's good to be consistent. You know, it's a best practice workflow thing. And it's good to vet or to make sure that any route-based data is done by a qualified person, is actually being entered properly. So there's always room for error in that case. And another variable here is, you know, calibration, accuracy, and traceability. It goes back again, you know, we started off talking about the quality of the data coming in. You know, again, it's good to understand if you have an audit trail on your asset, you know, calibration certificates, things like that, it's truly indeed traceable to some sort of a standard, or it has been calibrated and commissioned properly by the manufacturer or the maintenance department with a traceable device. Okay, moving on here, we have a poll question.
All right, so now Alex is asking to tell us a little bit about what challenge, based on what you've seen you need to do for trending and baselining, what is your greatest challenge? Is it establishing a baseline? Is it identifying trends? Is it figuring out thresholds to use for alarms? Or is it potentially setting up the maintenance workflows that occur? So if, again, these are only going to be shared in aggregate, let us know where you feel your challenges are, and hopefully then Alex will shed some light on how to deal with them. All right, looks like we have about 75% of the votes in, Alex, so we'll leave it open a few minutes more while people are, a few seconds more while people are thinking. Okay, let's go ahead and share what we have. So it looks like, Alex, 30% of our listeners said establishing a baseline is their greatest challenge. 15% said it's identifying trends. 24% said it's creating alarm thresholds. And 31% said creating maintenance workflows. All right, back to you.
Thank you. Okay. Back to our wheels of progress here, our gears of progress, we can say. So there's a, the baseline gear is out. We've covered that, and there's a trend, and we're actually going to get into that. And there's an analysis gear as well. So there's many components to get into the predictive maintenance, and we'll talk about trending and analysis at this point. So what you're seeing right here is an example of a SPC, or statistical process control chart. This was introduced by a gentleman by the name of Deming back in after World War II. But anyhow, what we're seeing some data from a particular asset coming in, and there's tools out there that you can apply the SPC to, and what it would do is automatically calculate a mean value and what we call upper and lower control limits. And so this is a great tool to use, to apply mathematics to your data. And we can see right here an example where we have established, and these control limits are actually established by the program based on the performance, of that. But again, I had to tell the program that, hey, this is a normal operating condition. But you can see right there that we're starting to trend in a certain direction. There's different types of trend types, and it's interesting in the poll that it seems like the least amount of people have trouble identifying trends, and this is pretty obvious. The key takeaway from understanding trends or recognizing a trend is just to see that is there a change or development in the general direction is what you're really looking for. Sometimes, though, people can fall in the pitfall of like overreacting, and saying, oh, now obviously you see the stable trend right there, but the ascending and descending trend are pretty obvious, but the variable trends many times can be challenging to deal with. Here I have an example of a control chart established for a particular asset, and there's two more limits that are actually on here, and these limits would be specification limits. So I want to make a distinction between control limits and specification limits. The specification limits are usually set by the manufacturer, the operations. This could be off the nameplate of a particular unit or an asset. It should operate within these particular specifications, but it doesn't necessarily mean that's where it's controlling at. And so just want to make that distinction right there. In this particular case right here, we draw the best fit line, and we can see a trend line where this would actually start to see, without the trend line, you can see right there where it seems like it's normal, although we exceeded a limit, but you can see it's starting to trend up a little bit. Okay, now we'll jump right into another poll moving along here.
Okay, let me go ahead and ask the next question. That'll sort of introduce the next topic. How are you currently tracking your asset performance data? Is it being manually entered? Is it acquired in real time, through some form of system, PLCs, SCADA, DCS, or it exists, but it's not currently in use? And again, this will help you also see where you are relative to others. One clarification for those, we have some questions coming in, and please keep those questions coming at any time. And at the conclusion of Alex's presentation, we'll go ahead and read them and get them answered for you. All right, looks like we have 70% of the votes in. Give it a few more seconds. Okay, let's share them here. So, Alex, 43% say it's currently manually entered. 24% say it's acquired real-time through some form of system. And then 33% are saying, well, it exists, but it's not currently being used for maintenance. All right, back to you.
That's a pretty good spread right there between all three answers. Very interesting. Okay, so we'll talk about analysis and reporting. So now you have your data, your baseline's established. We know we can spot trends, and so what can we do with this data once we have it? And what tools can we apply to understand where to set thresholds and alarm limits? And One tool that I've come across, or one aspect of things, is correlations. So many times one particular indication may not be from an asset, may not totally tell how that asset's performance. It's just a particular indication. There may be several different types of readings that may need to be looked at the same time from that asset. For instance, temperature, vibration, maybe the three-phase power coming into that particular motor. Because if we see a change in the asset, the first gut reaction is, is really, is not of panic or anything, but before you have to make any quick decisions on it, it's like, what, is this thing really starting to go south on me? Or is there a problem with this asset? And usually, if there's if there's another indication that coming from that asset, the first inclination is to look into those other indications and try to find a correlation between the two. It seems fairly obvious, but you'd be surprised many times out there where I've been on site and I say, hey, this particular asset's trending in a particular direction, but the other two are pretty stable. It can also point to you where a particular problem, in the asset starting to occur. If it's drawing more current, for instance, it could be for several reasons. Maybe it's a motor speed control as opposed to the actual bearing, for instance, on a motor. This is where it's important to understand what's the piping and instrumentation diagrams, the P&ID. If there's any asset diagrams, earlier we discussed about understanding what's upstream and downstream of that asset, things that can affect that asset performance. It's sometimes it's good to get out there and understand the entire system, which seems obvious, but it's surprising how many times that other components of the system aren't really looked into. Sometimes it's worth going beyond the asset to understand what's upstream and downstream effects can be. This is really a big one in many cases. Another helpful thing is an audit trail. A CMMS system has audit trails in there. If you pull up an asset and look at the history of that asset, it's good to look at the audit trail, especially in the cases where manual data is being entered or situations where the trend may change. If many times, it's really again, we talk about a behavior, and this is one of the behaviors that I find many times it's not practiced. It's surprising to me, but an example would be an asset has a change in its performance in the trend, and it turns out that it was just serviced. Many times I've gone out there to work on a particular problem and do the investigation, and I found out, oh, by the way, it was serviced by this time, but there's no audit trail. Audit trail is a very powerful tool to have, and a good CMMS system can do that for you, to understand the performance of that asset. It's kind of like the history of the diary of that asset, if you will. Anytime you have a change, it's good to be thinking of what the assignable cause is of that trend change. And after you've run across these assignable causes, you'll find that many times that it could be reoccurring, and it could be for some other, we talk about upstream effect, but if you use that audit trail and you record the assignable cause and it occurs over and over again, there's some correction that can be done to the process or these upstream effects, but it really helps to understand what's going on with that asset. Okay, rules established. What I mean by that is that earlier we saw the trend that was going up, and when do we react, when do we overreact, or when is the right time to actually trigger an action is what I'm getting at. So we see an upward trend and maybe it bounces off the control limit one time. Is this something worth alarming off if it's going to fall back within a limit again? This really is variable depending on the type of asset and the operational that you're in, the conditions. for instance, a basic type measurement of temperature is one thing, but if you're looking at the output of a motor or something like that, or maybe it's a production device that's sending an output and then recording this data, or maybe it's like a vibration reading coming in from an analyzer that's being manually inputted, and it comes in where it's showing some vibration. Do you shut the asset down? It's good to know that there's something going on, but you want to establish these rules, and this is really an evolution. This is what I've seen. My experience is it's like an evolution for some assets to get to the right type of reaction for that particular asset. In some cases you may want to just go and do a quick check on it and maybe do a resample and see if it comes in again. And it could be variability in the operator, how they're taking that particular measurement. It could be human error, when the data point's entered. It has to do with the integrity of data coming in. Okay. With the what we talked about earlier in those control charts, you can set the limits based off, mathematics, the SPC type of math. These programs are available out there. But really, the control thresholds can be set based on the data, but sometimes it could be straightforward, where the operating limits of that particular asset. On that plate of the motor, it says maximum current. If you exceed the maximum current, you want to be alarmed. You can set the threshold to that. In some cases, but sometimes it's too late in some cases. So you want to make sure that you're catch it in real time. This is where it comes into predictive analysis of the data. There's many complex types of things that can happen as far as trending is concerned, and how we can, what we call trend rules. There could be like so many consecutive points on the same side of the center line. There might be consecutive points steadily increasing or decreasing, points alternating up and down. And when I say central line, I'm talking about the mean value, which is the average of the data. So these, again, this is an evolution, and it really depends on the type of asset that you're using, but there is definitely a way to establish control threshold or upper and lower control limits. The limit alarms are straightforward. It could be different. You can actually have control limits, which prompt one sort of reaction, and you have like alarm limits. If you have a particular measurement, let's say it's temperature or pressure, and you exceed the threshold at pressure, it's definitely an upset condition, and you can get an alarm in that case. Maybe a push notification on your phone, a work order to go out and look at it immediately. But the control threshold, in a sense, is kind of telling you there's something starting to occur, and it's worth looking at, a little bit further. So in that case, it's good to have some sort of a tool, automated tool that can generate a work order for you, like a CMMS system, some sort of condition monitoring system, maybe send a push notification to your phone. These are great tools, especially when it's after hours, and it's kind of like really it's a system kind of babysitting the asset for you and gives you a little bit of sense of reassurance that everything's operating properly, and the main thing is that you're not going to have any downtime. Okay, moving on here. So here's an example of a threshold alarm right here, where we can see some data here, and clearly, we've exceeded the maximum temperature of 90 degrees here, and we have an event alarm. Okay, this leads us into poll question number 4.
Okay, let's go ahead and launch poll question 4. I believe this will be our final poll to just ask our listeners, what best applies to your organization? You have a system to monitor your performance and trigger work orders as described, or maybe you don't have the bandwidth to really be able to measure asset performance, or perhaps you're not even monitoring it. All right, so which applies? You're not monitoring it, maybe you're monitoring it, but you don't have the bandwidth to analyze it, or you really do have a system in place to monitor it and kind of close the loop and track. So it looks like we have 2/3 of the votes in. Take a few more seconds, and then again, thank you for your questions. We'll get to them as soon as we're done with a slide presentation. All right, let's go ahead and look at our final poll here, Alex. 35% of the audience said they have a system in place to monitor asset performance and trigger work orders. 21% say they don't have the bandwidth to analyze asset performance, and 44% say they're currently not monitoring asset performance. All right, back to you, Alex.
Okay, that's an amazing set of replies there from one end of the spectrum to the other. But that's really the reality that you run into. Bandwidth being a big one. Okay, so we talked about some assets that you got a clear set of data output coming from it, and I want to use the final part of this this time to discuss a more complex type of asset trend, and something that's becoming more and more common in industry is using infrared cameras and how to baseline with infrared thermography. And if we look in this particular case here, we're looking at a particular pump motor and with the thermal camera. So in these cases, you're going to go out on a routine thermal and take a scheduled route-based type thermal measurements. Things to consider. Is the point of reference taken at the same point every time? I've seen situations where I recommend actually putting maybe some X's on the floor or some sort of a marker where to stand, how far to stand away. It's good to get out there in the initial, when you set up the workflow or the procedure on how to do it. Can't tell you how many times we've seen different, the thermal camera in the hands of different operators and who maybe don't have any thermography training, and it doesn't necessarily have to have the training. It's good to have a base type of training in it, but if the camera's set up properly and the stand, it's just really a focus point and shoot type of situation. But these are things to consider as far as being consistent and the quality of data coming in. The time of day can be a difference too. So you would catch, with the time at which you're actually capturing that particular data is important, because this is just a snapshot in time. And it's really the assumptions made that you're taking this under normal operating conditions. And that's really important to make sure that the time, what's going on with the asset at the time the image was taken. And if possible, to capture all operating conditions. It's also good to have a startup and commissioning images, but I do want to say that some particular assets may require a break-in period, and the process sometimes, when it first starts up, doesn't necessarily mean things are stable. And the tendency is to go out there and take thermal images, right after startup commissioning, but really what you need to be thinking about is this normal operating conditions? Have things stabilized, as far as this particular asset is concerned? So if we look at the two images here, and using what I mean by radiometric type of thermal image is that any point on the chart right there, or on the motor itself, I can mouse cursor and actually get a temperature indication. So it's good to monitor, identify certain areas and know what areas you need to monitor on that asset. What are the risk areas, by the bearing, so forth. And so once you identify those areas, you can set up multiple, depending on the type of camera that you have, but you can set up multiple points to monitor. And this is where it gets, in a sense, you can actually use the SVC method or digital method to trend the data. You're saying, how can you trend in an IR image? Well, what you're doing is you're actually trending the output of those particular points. So there's a digital number associated with that particular point. So you can plot these readings, and in your system, you know the point at which these readings taken. Again, it may be several points on that particular asset that you're taking, so it's good to make the distinction to be clear, you know, in this radiometric measurement, which point you're actually taking and monitoring that. And it works at that time, you know, it could be analogous to like a temperature transmitter output where you're just plotting data points of a particular temperature at a given time. Again, I'll reiterate that the pitfalls into route-based maintenance is really just a snapshot in time as to a continuous monitor situation where you got more data coming in. The more data, the better. And so, as we getting to the end of this this session here, you know, it's many times I hear I've got huge amounts of data, I don't know what to do with it. You know, just I say one asset at a time. Data is a good thing. You know, it's understanding the quality of that data, going back to the beginning. You know, that you have there, and feeling confident. And it's just more than just going and looking at the data and applying statistical, you know, process control tools and analysis tools. It's understanding what's behind the data, you know, how it was acquired. Again, you know, we talked about the averaging, you know, the asset being spec'd right. Just to recap, you know, it's just a thought process to think about on each particular asset. The data is like really be thinking about the quality of the data, and the rest of it will kind of fall into place for you. And that concludes today's session. I appreciate everyone attending.
Great. Well, thank you so much, Alex, for presenting that and sharing your knowledge. So Alex has agreed to stay around a few more minutes and answer your questions. So please just go ahead and type them in. And also, we've had several people ask about the presentations. We will share a copy of the slide deck and the recording either later today or by tomorrow morning with all of our listeners there. So, Alex, here's a few questions that came in during the presentation. One person asked, when you talked about upper control limits and lower control limits, how many data points do you feel you need to be generating to have those be accurate?
Again, you know, there's no set amount. I mean, there's a minimum amount of data based on the mathematics that's used to set those limits. But you want to have as many points as you can, as possible. You can have as few as, like, let's say, 5 data points. It becomes riskier the less data that you have to work with. Because really, if you know to establish that baseline, you want to have confidence. If you're taking 5, especially in a noisy situation, what I mean by that is if your data is variable, you want to collect more data and try to understand the cause. It just may be the output of the way things are working in that process. In some cases, it may be very stable from the very beginning, and what I mean is from the average value, it's not really moving up or deviating too far from the mean value. But that's a good question. And my answer to that is as much data as possible, understanding that in some cases, you know, if it's route-based, it may not be possible, but it's really best practice to have a good portion, a good amount of data to establish control limits.
Perfect. And Alex, someone else is asking, apart from statistical techniques, which you touched on, is there any proof of more sophisticated algorithms such as machine learning or deep learning? Do you have any use case or examples where those are being used successfully for predictive maintenance?
I do. There's some of the oil and gas customers I visited have some tools that they've used, and I could say there's programs out there, you know, that can do this. I think a good starting point is actually using an SBC type of tool, and those are numerous ones out there. Jumping right to predictive, you know, is one thing, but you can still establish limits with, you know, SBC, you know, trend rules. But yeah, that's something that's out there. Sometimes it's complex. You know, you have to get a process engineer involved and understanding. You know, just one particular customer, they had to understand many aspects of their process to actually make predictive, and this is where the correlations come in. And I will say this, a lot of times the predictive analysis includes more than just that one particular set of asset data. It's correlating it with other information.
Very good. You talked about triggering alarms, but someone is asking about do you have any recommendations when you're setting up a default timing for preventative maintenance work order? What methodology do you recommend? A little bit of a departure from your topic, but preventive is part of a predictive program as well. And do you have a particular methodology that you favor?
Yeah, I think if I understand the question clearly, it could be the frequency of preventative maintenance and when to do it. It's a good question because, and I've been in this situation many times where I've installed new pieces of equipment for a customer, and how often should I calibrate or check the calibration or service it? And my first, I always had the same answer. You start off as often as possible. That's reasonably, that's cost effective for you, but if you go in and check the calibration, keep in mind that every time you calibrate a particular device, you introduce more variability. So it's best practice to actually check the calibration and don't make any changes to it unless it's not within the specification. But yeah, so after a period of time, you're going out there and you're seeing that after checking the calibration or PMing it, there's really no change that occurs. And there's no need to go out there as often. But you don't know this until you actually do the work. Maybe after 6 months, you have in your plan to start off doing it every week or every 2 weeks, and eventually you say, hey, after 6 months of doing this, I realize that I only have to do this every quarter or every 6 months because this is what I've learned. So it depends on the asset. I hope I've answered that good enough.
I think that the listener could respond in, and what he was really referring to, and I apologize I misinterpreted, was the length of time the technician should spend executing the work. I guess for preventive, when you're setting up your standards, what method for time to complete preventive? Does that?
Okay, the time to complete a preventative maintenance work order or procedure has to do with the type of asset that you're working on. It's really dependent on the type of asset. It's hard to say the amount of time they should pin, because they're following a procedure. With that said, you definitely want to have workflows and procedures. Keep things standardized, and then you can track the time, from the particular resource going out there to do it. Qualified resource, I should say.
Right, and we often, just from our own listeners tell us they often start with the OEM, recommendations and then continue to measure and benchmark to come up with standards and establish SOPs. Alex, you shared some slides about, kind of that journey from preventive to predictive and all that. Are there any industry averages for an optimal or benchmarks for what's an optimal preventive, reactive, preventive, predictive ratio, or particularly predictive versus reactive or corrective? Can you share any stats or even places where people might go to get that kind of industry benchmarking?
First of all, it's industry dependent. It depends on the type of measurement, the type of process. It's highly variable from one industry to the next. And so I would look at the industry governing agencies, maybe have that if it's if it's like oil and gas and the American Gas Association may have that type of information. That's usually a good source is to find the governing bodies of that particular industry. That's a good source for that information. I'll also add maybe any sort of reliability, groups within the industry.
Such as like SMRP or that type of, those type of groups, yes. And again, I guess like everything else, you start to trend it, right? Or you measure it and you just want to see steady improvement. Very good. Someone had a specific technical question, if they're still on the line, asked about your experience with use of triaxial versus dual axis accelerometers for use in vibration analysis. Is that something you've had experience with, Alex? If not, we'll take other questions.
Yes, I do have some experience with that. It's measuring a mechanical. It's a transducer that measures, mechanical, and you're actually converting mechanical energy into an electrical output. And the crystal that's used in those particular accelerometers can be set up, and 2 axis is a 3 axis, really the plane of measurement or movement. If you're moving laterally or vertically, if you will.
Great. Okay. I think we have time for one more question. And someone is saying that they're currently trying to establish a PM plan and a CMMS. And hats off to someone who starts with a plan. That's great. And they have a large number of pumps and motors and some smaller assets, but they're starting from scratch. And this kind of dovetails, Alex, where we saw 44% of people aren't monitoring yet. So I think what they're asking, how do you focus? How do you decide as a criticality? How do you decide where do you start to focus to get the ball rolling?
It's easy. You talk with your operations people, and that's always good to have a relationship with the operators. Many times I've been out in the field, and you could go into a process engineer. Maybe someone's only been there a couple of years, but how they say sometimes the captains come and go, but the servers from the stay. There's a lot of operators out there with many years of experience. But just getting back into operations is really the key to that, understanding the operation, and by that you understand what your critical assets are, and you want to focus on those first. Which ones that will bring you to your knees, if they go down. Those are the ones you want to focus on first and kind of branch out from there.
Perfect. And we have sessions that we've done previously that are on the website about asset criticality, as Alex is alluding to, and how you even determine, and some tools to help you decide your most critical assets. Well, Alex, I guess to our listeners, we're out of time, but we've had many people type in and say, thank you, Alex, for sharing this information and how helpful it was. There's a lot of data out there and helping people get started, or they have already started making better sense of it and knowing that they're on the right track. So appreciate, Alex, you taking the time to put this together, and we appreciate all of our listeners joining us. And when we conclude today's session, we will have a brief survey. Please take a moment and let us know, how did we do? And also suggestions, what other topics would you like us to present? We have a team, there's Alex and a whole team of, really application experts with vast field experience. And we want to make sure we're giving you information that really helps make your life easier and solve some of your greatest challenges. So Alex, thanks again, and thanks to our listeners. And Alex, where is that? Are you hosting webinars these days? Where else are you going to be where our listeners might
I do rotate hosting webinars on occasion, but my contact information is on the first slide, and feel free to reach out to me if you have any questions or any further explanation on this topic or any other topic for that matter. It's been a pleasure.
Great. And we'll be sharing more with our listeners about the upcoming Accelerate conference in November. eMaint and Fluke are going to be doing, it's a multi-day conference with a lot of opportunities for training. So we'll be sharing more information on that. So thank you, Alex. Thanks to our listeners, and we hope we'll see you all the next time. Take care and have a great day.